Hello everyone, my name is Tasnum Alam, and for the graduate paper presentation, I'm presenting the paper named Walking Dynamics in Pre-Adolescence with or Without Down Syndrome. The paper is by Dr. Wu et al. And the paper is published in 2015. So I'm going over the motivation, contribution, methodology, conclusion, limitation, and at the last we will have our references. For the motivation, the children with Down syndrome manifest a slower self-selected walking speed compared to the typically developed children due to their existing motor deficits. Walking at a faster speed with ankle load paradigm can be advantageous. Designing intervention program to improve the motor adaptability in the children with Down syndrome. However, little is known about how the children with Down syndrome modulate the mechanical property of the neuromuscular system during walking. So here comes the FDHO model, a novel way to investigate the neuromuscular skeletal system's elastic and gravitational properties during walking is that the force-driven harmonic oscillator, or the FDHO model. The FDHO model consists of a simple pendulum that is the thigh, shank, and foot system, and a spring-like structure like muscle and the soft tissue that is attached to the pendulum. The primary variable of the system is actually the kg ratio. The kg ratio is equal to 1 is actually indicate normal walking pattern. If the kg ratio is less than 1 is actually indicate some impairment or disruption in the walking. So the paper that is published in 2015 contribute toward understanding the motor adaptability in children with Down syndrome during the walking. So the paper investigated if the children with Down syndrome showed a lower ratio between the elastic and the gravitational torques, that is their walking performance is worse than the typically developed children, and then it also investigate if the ratio changes at different walking speed, whether it's improved or worsen, and then whether the children with Down syndrome take advantage of the ankle load, whether it helps them to improve the walking or maintain the kg ratio similar to the typically developed children, and at last if the typically developed children and the Down syndrome children have the kg ratio similar at their preferred comfort level, that is the motor adaptability. So for the method, there are 26 participants who participated in the study. However, unfortunately, there are only 20 participants who completed the study. There are 10 participants in each group, and they age between 7 to 10 years. The protocol included 2 laboratory visits. The first visit included all the protocol in the overground walking. So in the overground walking, each participant walk at a normal speed and 75 to 100% faster than their preferred speed. So at the normal speed, they would walk with 2% of their body weight ankle load or no ankle load. Also at 75 to 100% faster than their preferred speed level, they would walk with 22% or 2% of their body weight ankle load and with no ankle load. For the second laboratory visit, they will perform the whole protocol on treadmill. So on treadmill, they would walk on normal walking speed with 2% of their body weight ankle load or with no ankle load, and with their 75 to 100% faster than their preferred walking speed. They would also walk with 2% of their body weight ankle load and with no ankle load on the treadmill. And each of the participants actually completed 4 trials for the analysis. And the study uses MATLAB. All the process data were exported as a text file and analyzed with MATLAB. A custom-written MATLAB was used to calculate spatiotemporal parameters, including speed, cadence, stride length, and time. The specific MATLAB program code determined the gait events of heel contact to toe off. For the statistical analysis, the paper used the Dr. Wu et al. Paper used SAS statistical analysis software, and they used three-way repeated measure ANOVA, assuming the variances are equally distributed. So the conclusion, the children with Down syndrome actually showed a kg ratio comparable to their typically developed children during overground walking at normal walking speed and the fastest speed regardless of the ankle load. Interestingly, the similar trend was seen during the normal speed treadmill walking regardless of the ankle load. However, the kg ratio decreases at a faster treadmill speed but improve with the ankle load. So this study is not without the limitation. One limitation includes small sample size. The study did not use any equipment that will measure the muscle activation level. So an inclusion of electromyography can be used to understand the muscle activation pattern or the coordination pattern. Also, the study only looked at the kinematic data from the treadmill walking and kinetic data from the overground walking. So it would be helpful if we can evaluate all the variables from all the trials. Here I have included the references, and that's all for my presentation. Thank you.